Now we're going to talk about ratios. Ratios are a way to just compare sets of numbers to one another. If there's a ratio, there's a relationship between the numbers. Quite often you will find ratios being written as 10 to 25 to 15, say, for example. In this case, we're comparing the ratio of three numbers to each other. Right? 10 is to 25 is to 15, right? Sometimes you'll be asked to reduce these. Now, they're similar to fractions in the sense that you got to try and find a number that will divide equally into all three of these numbers. Well, we know that if a number ends in 0 or a number ends in 5, that means that number is divisible by 5. So 10 divided by 5 is 2, 25 divided by 5 is 5, and 15 divided by 5 is 3. So I can reduce my ratio 10 to 25 to 15 to 2 to 5 to 3. What's also nice about ratios is you use them in all sorts of mathematical equations. For example, I could take a triangle, say a right angle triangle, and I could have the sides being 9, 12, and 15. Now I can compare these sides in a ratio format, so I can say, well, 9 is to 15, or 9 is to 12, or 9 is to 15 is to 12. I can also write ratios as a fraction form. If you compare just two fractions or two numbers as a ratio, you can go say 9 is to 15. But I personally like to write it as almost like a fraction. 9 is to 15. Or I could say 15 is to 9. Either way, it doesn't matter how you write it. But the reason that I like to do it as fractions is because it allows me to compare items. So if I wanted to compare two triangles, I had 9, 15, and a 12 for this triangle, and I want to compare it to a similar triangle that had the numbers 12, 16, but I didn't know what that one side was. Right? It's going to be up to me to solve for that one side, solve for the unknown. If I set up my ratios as a fraction, I could set up my unknown being put again on top. So let's go x is to 12. There's one ratio, but because these triangles are said to be similar, I can then go, well, the long side, there's my right angle, so it makes this here hypotenuse, makes that my hypotenuse. So my hypotenuse is the x on the big triangle. So if my x is upstairs, I got to have my 15 is upstairs. So I'm going to compare it to 15 on this triangle is to, well, on this side it was 9, so I'm going to do, or on this side it was 12, so this side is going to be 9. Now I can solve. I have an equation set up. Any equation, my goal is to get to solve just strictly for x, something equals x. Alright? In order to do that, by setting up as a fraction, that's a divided by sign. Right? That's where the divided by symbol comes from, a number over a number. So right now I have x divided by 12 equals 15 divided by 9. I need to get x all by itself. In order for that to happen, I have to get rid of a divided by 12. How to get rid of a divided by 12? Well, I multiply by a 12. Now, whatever I do to one side, I have to do to the other. The reason being is an equal sign is like a teeter-totter. If I can just throw on a times 12 onto this side, I have to throw on a times 12 onto that side. So, let's clean this up a bit, and we'll start off again here. I had 15 over 9 equaled x over 12. I need to get rid of divided by 12, multiply by 12, whatever I do to one side, I do to the other. these two, times 12 cancels out or divided by 12 because they're exact opposites, leaving me with an x on that side of the formula. The right side of my formula is now solved. So on this side, I have to go 12 times 15 gives me 180 over 9. So 180 divided by 9 is 20. That equals x. There's my 20 equals x. I've solved the equation. There you go. That's ratios.